Welcome everybody to the review video for the Unit 1 test in Algebra 1 at Freedom High School. So here are the first 4 questions on your review. Number 1, write an expression that correctly represents double p less than p to the second power. So double p would be 2 times p, less than, now there's no is in there, so it's not an inequality, is going to be minus p, and to the second power is that. Write an expression that correctly represents 10 more than the cubed product of p and q. So 10 more is easy, that's 10 plus. But it's the cubed product, so we're going to cube something that's being multiplied, which in this case is p and q. Whenever you see something like cube product or the product of the sum, you're cubing the product, not these, so you must put it in parentheses. Write an expression that represents the quotient of the square root of y and 10. And some of your teachers will write it like this. I would really prefer we write it as a fraction, but go to what your teacher tells you. Remember, this is the symbol for square root. Write an expression that correctly represents the absolute value of the difference of a number cubed and 5. So it's the absolute value, but it's the absolute value of the difference. So what's inside the absolute value is a number cubed and 5. So those were the first 4 problems. Those are the verbal to algebraic problems. Number 5 we'll do as a standalone. If 45 children sign up to ride the bus, and each bus carries X children, write an expression that could be used to determine the number of vehicles needed for the trip. Sorry, let me answer this phone call. I'll be right back. Sorry about the interruption with the phone call. If 45 children sign up to ride the bus, and each bus carries X children, write an expression that could be used to determine the number of vehicles needed for the trip. So we know there's 45 kids. So if there were 10 kids we could put on a bus, we would divide by 10. We don't know how many kids fit on a bus, though, because it's X. So it would be 45 divided by X. Move on to number 6. What is the value of 3 times p minus 2 times q all over pq? So we will go 3 times 2 minus 2 times negative 7 over 2 times negative 7. And that'll give us 6 minus negative 14 over negative 14, which is 20 over negative 14. And then if we reduce that fraction, it reduces down to negative 10 over 7. For people who are struggling with how to reduce a fraction, I will just show you that this is 20, negative 20 over 14 is 2 times 10 over 2 times 7, negative cell up front, and the 2's cancel. And that's where you get the negative 10 divided by 7. Number 7, what is the value of 2 times the cube root of p minus the square root of q when p is 27 and q is 48? Okay, so we're going to sub in, use substitution to put in our values. So this is really 2 times the cube root of 27 minus the square root of 48. Remember, if you see a little number here, that's called the index. And that means that it's, if you see a 3, that's a cube root. If there's no index, that means it's a square root. And if you evaluate this, this is 2 times 3 minus, and you're going to have to do, at this point, as the year goes on, we'll teach you how to write square root of 48 as a radical. But for now, we'll just write it as a decimal, which is 6.928. We'll go to 3 decimal places because that's the standard for calculus. And we'll get negative 9.28. For number 8, if the area of a triangle can be determined by evaluating the expression 1/2 base times height, where b is the base and h is the height of the triangle, what is the area of the triangle with a base of 6 inches and a height of 8 inches? So we would just say area equals 1/2 BH, but then they tell us B is 6 and H is 8, and that's decoding the sentence. And so the area is going to be 1/2 6 times 8, in inches, sorry, always put in units. Inches. And so you multiply that out, and that will give you 24 inches squared, because inches times inches is inches squared. All right, match each statement with the corresponding property. So here's where you need to know your properties, and we'll just go through this. This is, you either know it or you don't. So -5 plus 5 is something plus its opposite. So that's an inverse property, and there's addition going on. So that is going to be the additive inverse property here. For this one, look at what happened is they distributed the 5, and so that's going to be distributive property. For this one, 4 times 0 is 0. That's the multiplication property of 0. On the next line, what was inside the parentheses changed, which means it's the associative property, and we're using multiplication, so that is the associative property of multiplication. In this line, it's written one way on this side and then reversed on the other. And always remember your commute, and you go one way in the morning, you go the other way in the afternoon. And so that is the commutative property, and in this case, the commutative property of addition. This is also something times its inverse, and so that's going to be the multiplication inverse property. For this next line, -3 times 1 is -3. And despite what Terrence Howard says, anything times 1 is itself, and that's the multiplicative identity property. Once again, on this next line here, what's inside the parentheses changed, and so that's the associative property. But this time it's the associative property of addition. On this next line, a lot of people get confused, but no, we don't have an example of that here. Is if you look at it, this is actually the same. If we go this way, the 2 is distributed, remember the equal sign goes both ways. So that's the distributive property again. On this problem, anything plus 0 is itself. So that is the additive identity, which is A. Four x plus 2y equals 12, then 12 equals 4x plus 2y. That is the reflexive property. And the reflexive property is why both of these are the distributive property. It's important to remember that the equal sign flows in both directions. The symmetric property is anything equals itself. And then the last one here is if this is the transitive property. If A equals B and B equals C, then A equals C, which is what we see here. X equals 3y, 3y equals 30, so X equals 3y. We didn't use the substitution property, but substitution property is when you define a variable and then say, so you say if, and then, but then we're going to plug in the 3. So we didn't change something, we didn't change equal signs, we substituted in a value. Hold on. I really shouldn't make videos when I'm not feeling well. But hopefully we still have sound. I just realized I made a mistake. Even math teachers make mistakes. So I said that I got M and F messed up. This is the symmetric property. This is the reflexive property. I get those confused. So you're going to have to come up with a mnemonic to remember that A equals A or 10 equals 10 is the reflexive property, but that the equal sign flows in both directions is the symmetry property. See, even math teachers make mistakes. I apologize. All right. Number 10, the real Slim Shady wrote these steps in solving an equation. Step 1, step 2, step 3. So what is the property that justifies step 1? What property allows a student to go from here to here? And so what you look at is this side of the equation change to this, which means that they have to be equal. So 12x minus 2 has to equal 12x minus 24. And if we look at that, that is clearly the distributive property. Sorry, Smartboard freaked out on me there a little bit. Number 11. If 5n equals 10, what property of equality justifies writing p plus 5n equals 3 plus 5n, 7, as p plus 10, and that is so we change this into that, which is the substitution property. Which was the missing one from that matching. All right, evaluate the expression. You may earn additional points by showing all your work. So we're going to substitute in. So it's negative 2 times the absolute value of 7 minus 9 plus 5. We have to get the absolute value down to a single number before we apply the absolute value function. And so the absolute value function will, the absolute value of negative 2 is 2. And so we'll get negative, then we have to follow our order of operations. We do multiplication before we do addition. And so we'll wind up with 1. If at any point I'm going too fast, remember, you always have the option to pause the video. So, for this one, once again, we're going to sub in. So 5 times 6 minus 2 times negative 5. Remember, when you sub into the calculator, always put your substituted in values in parentheses. So we evaluate the numerator and the denominator of the fraction. So that'll be 30 plus 10 over negative 30, which is 40 over negative 30, which is negative 4 over 3 times. And so you just reduce the fraction. On to number 14. So we're going to substitute in. So this will be 3/4 squared plus 4 times 3/4 minus 5. So when you square a fraction, you square the numerator and the denominator. Here, when you multiply across the top and the bottom, you will get 12 over 4, which cancels down into 4, minus 5, which is going to be 9/16. And here, minus 1. Oh, I don't know what happened to the smartboard there. I apologize. We'll try that again. Which is going to be 9/16 minus 16 over 16, which will give me negative 7/16. It's always important to go back and check your work, because when I went back and double checked, I realized I made a mistake right here. This should be 3. So this is 9/16 minus 2. So that's 9/16 minus 32/16, which will give me negative 23/16. Apologize. Always double check your work. And the last problem. Nope, sorry. This is for anybody who wants to learn an SAT vocabulary word. This is the second to last or penultimate problem. Is we're going to sub in. So the square root of 144 plus negative 3 cubed. And so the square root of 144 is 12 plus negative 3 cubed is going to be negative 27. And that will give me an answer of negative 15. Now the last problem. So this is going to be 3 times the cube root of 64, but everything inside the parentheses is going to be squared. I'm sorry, that parentheses was almost. And so first we have to evaluate the cube root of 64. Which is 4. So this is 3 times 4 squared, which is 12 squared, which is 144. If you have any questions on these problems, or you found a mistake I've made, please bring it to your teacher. But otherwise, good luck on the exam.